cover one more thing with this chapter and really specifically look at residuals. Residuals is, we have data points, there's going to be some regression line, and it's the distance that one particular point is from that line. We saw that we have categorical data, we have our observed and our expected, and with that we can calculate the residuals between the two. And that goes like this: observed minus expected over the square root of the expected. So I'll demonstrate one of them. We'll look at those that have hepatitis C and those that go to a tattoo parlor. So 17, that is my observed, and 3.9 is my expected. So I'll have observed 17 minus my expected 3.904 divided by the square roots of expected 3.904. And that should equal 6.628 right here. So here's my observed expected table. Doing my formula here gives me my residual table. Now, look at that table. If we can recall, each cell of the contingency table contributes to a term in the chi squared. I've heard some people say chi squared, but it's also chi. I know this is another way of saying it, but we'll go with chi because that's what I hear mostly online. Had to double check, make sure I was saying that right too. As we did earlier, we should examine the residuals because we have rejected the null hypothesis. So remember when we did this? We rejected it. And if you reject it, check the residuals. If patients with tattoos are more likely to test positive for hepatitis C, perhaps physicians should be advised to suggest blood tests for such patients. So looking at this data, what do you notice? What stands out? Look at the numbers.
There's negatives.
There's negatives. There's positives. Is there any one negative or positive that's bigger than the other?
Yeah.
Yes, which one?
The non-hepatitis
Hepatitis C and what?
None is the lowest.
Okay, and none. Here. So what do you think that means if I have a negative residual? People with no tattoos are what in regards to hepatitis C? Yeah, less likely to get it, right? And who do you think is more likely to get hepatitis C based on the residuals? Tattoo parlor, very good. So if I focus on that one, this cell tells me that people with tattoos obtained from a parlor are very large in getting hepatitis C. And positive. So this indicates that there are more people in this cell than the null hypothesis of independence would predict. Maybe tattoo parlors are a source of infection. Maybe. Again, we don't ever find causality. But, or maybe just people who get tattoos are more likely to be risk takers, and risk takers could be more likely to get hepatitis C. Point is, I found something here. Might want to investigate further. Likewise, when you pointed out with the negative here, I see that the second largest component is a negative component. Those with no tattoos who test positive for hepatitis C, the negative value says that there are fewer people in this cell than the independents would expect. So, if you can remember, we ran our null that this is equal to 0, and these are either above or below 0. So this is greater than what my hypothesis was, this is less than. Looks like more people in parlors are likely to get hepatitis C, and people without tattoos are less likely to get it. At least as far as your results. Now, if you can recall, we had a failed expected frequency count condition, didn't we? If I go in here and I see this is less than 5. Any expected count close to the arbitrary minimum of 5 calls for checking the cell's standardized residual to be sure it's not particularly large. In this case, hepatitis C and tattoos elsewhere is not particularly large. Well, how would you judge that? Our degrees of freedom was it 2, I believe? So it is less than that value. But hepatitis C and having tattoo parlors is particularly large. The fact that this is such a small count, it could affect any other cell within here. So what would we do? Well, we might choose not to report the results because of concern with the small expected frequency, because it didn't pass that condition, so we just throw it away. Or we could put in a warning report. So in my conclusion, I just want to make clear that this did not pass that particular condition. So take the results as you will. Or a better approach would be to combine our categories. So let's combine people who have tattoo and people who didn't. We get this table right here. And notice, now I passed the expected condition. So I might want to run a chi test based on this result, or this table. And you'll see that it does, in fact, we still reject the null. So I'm a little bit more confident in this result with this table than I am with this one here. Does that make sense? Okay. Well, let's look at one more example. Many states and localities now collect data on traffic stops regarding the race of the driver. The initial concern was that the black drivers were being stopped more often. With more data in hand, attention was turned to other issues. For example, data from 2,533 traffic stops in Cincinnati reported the race of the driver, black, white, or other, and whether the traffic stops resulted in a search of the vehicle. Looking at this, let's assume we've already ran all the data. Cincinnati traffic stops of the data, see if police decisions about searching cars show evidence in racial bias. With a degree of freedom of 2, technology calculates the chi-squared value of 73.25 and a p-value less than 0.0001. And these standardized residuals. Based on this, what do you see? Or what is your conclusion? Look at it. Think about it. Don't just tell me whether or not you accept or reject the null, but what do you notice about the residuals? What stands out? So tell me, if our null hypothesis, there is no difference, so the alternative that there is a difference, would you reject or fail to reject? Reject, right? This is less than 0.05. So I'm rejecting null, so I'm saying there is a difference between the race of people and whether or not they get their car searched. Now based on the residuals, since I reject it, let me check out the residuals. What does the residual say? What do you notice? As far as the yes column, who has the largest? Black drivers. As far as the no, who has the largest?
No.
White. So you can conclude from these residuals that what? There is racial bias.